All right, greetings, you two. Beautiful mind here. So let's see. We have another question from calculus. It says, consider the following limit. The limit as x approaches 2 of this expression. Simplify, and if the limit exists, evaluate the limit. Okay, so let's see. So off the rip, let me see. Now, whenever we're working limits, you want to try, okay, sometimes you can plug it in, right? So you just try. You plug it in and you got to see what you get, right? So if we plug in 2 here, we're going to get 2 plus 2 is a 4. Square root of 4 is 2. So it looks like we're going to get a 0 in the denominator, right? So we can't work with that. Now, at first glance, I notice we have a radical in the denominator. So then we might try. So we're going to use this technique. It's called multiplying by the conjugate. We're going to multiply by 1 in the proper form so that we can essentially, I think we should be able to get rid of that square root in the denominator. And so again, it's either rationalize, but in this case it's gonna be called what's called multiplying by the conjugate. And I feel like the simplest way to kind of do that is just to do it. To explain it is just to do it. Okay, I'm gonna go here. So if we take this guy, so the conjugate, we're going to multiply by 1 in the following form. So again, if we multiply by 1, it doesn't change our answer. It just changes the form into something that we can use, right? We're going to multiply by 1 in the following form. We're still going to have this square root of x plus 2, and the conjugate comes here. Instead of a minus, that's a plus 2. Right, and again, we're going to do that on top. So again, we're just multiplying by 1. We're not going to change the final outcome. We're just manipulating it so that we can put it in a form that we can use. Okay. So let's do this and let's see what happens. So I'm just going to bring the limit down. Okay. Let's focus on the denominator first. So we have a binomial times a binomial, which means we have 2 terms times 2 terms. So in this case, we can FOIL. First, outer, inner, last. So this times this is going to be that thing squared. So we can essentially lose the parentheses, right? I'm going to start by writing it as the square root of x plus 2 squared, right? So the squared is going to cancel the square root. The outer is going to give me plus 2 times the square root x plus 2. The inner is going to give me minus 2 times the square root of x plus 2. And the last is going to give me a minus 4. Okay, that's if we FOIL the denominator, we get this. Hopefully you notice something at play there. We're going to FOIL the numerator as well. First, outer, inner, last. Okay, so first times first, which is going to be this 2 times this guy, is going to give me 2 times the square root of x plus 2. Outer, 2 times 2 is a 4. Inner is going to be minus x times the square root of x plus 2. I'm just leaving it. I'm not really, And then last is going to give me a minus 2x, okay? So now there's some simplification that's at play here. All right, there's some things that we can combine or simplify. Okay. So for instance, we got this squared and the square root. Essentially, these guys are going to cancel each other. Okay. So then the first part just comes down. Okay. So then that first term, we have this x plus 2. These guys cancel, right? A number plus its opposite adds to 0. So then all that's left there is the minus 4. Okay, so we're going to come back and update that momentarily. On top, it's no real like terms. We could factor out that square root of x plus 2 from those 2 terms. I think I'm just going to leave it the way it is for the time being. Okay, let me think. If I factor that out, it's going to be what, 2 minus x times that? I'm just going to leave it the way it is for now. So we have this 2 square root of x plus 2. This 4 negative x, that's the square root of x plus 2. We probably could have left it the way it was in the above line, but I'm going to just leave it like this for now. Okay. So the whole point of this is that we get the square root out of the denominator, right? Let's see if anything happens now that we've done this. Let's see if we can plug in at this point, right? So, 2 minus 4 is a negative 2? And you know what? I feel inclined. I mean, it's fine. Let's just keep going. The limit as x approaches 2. 2 minus 4 is a negative 2. On top, let's do the top. So 2 times the square root of x plus 2. There's the 4. I'm just bringing down. I'm bringing down each item. Okay. Now on bottom, 2 minus 4 is what? Negative 2. So that's just the x minus 2. Okay. So with that, I need to put the top back where it was. Expanding it was too far. So I'm going to go back to where we have 2 minus x. And then square root of x plus 2. So at the top we had 2 minus x. We had square root x plus 2 plus 2. So I just went backwards because I see where something can cancel in just a moment. Again, limit as x approaches 2. Okay. So now in the numerator we have 2 minus x. In the denominator we have x minus 2. So we can get those to look similar by factoring out a negative 1 from the numerator. Okay. So then if we do this, the limit as x approaches 2, we're going to have a negative. Now it's going to become x minus 2. Then everything else kind of stays the same. Okay. X minus 2. Okay. So now with this manipulation, now we can cancel this guy, and that serves us a lot. I think where the radical expression is gone at this point now. Okay. So if we account for these changes, we could distribute that negative. We get the limit as x approaches 2. What's better? Yeah, let's do this. So at this point we have the negative square root of x plus 2 and then minus 2. Okay. So then now that we were able to do that cancellation, now we should be able to plug in. Now if we plug in or evaluate the limit, we're going to have negative square root 2 plus 2 is a 4 minus 2. Ultimately it's going to be a negative 4, right? Square root of 4 is a 2. Negative 2 minus 2 is negative 4. Okay. So that was not trivial. Not in the least. Can I zoom out? Let me see. Yeah. Okay. Simplify. So let's just recap real quick. So again, the main technique that we used was multiplying by the conjugate in an effort to get the radical out of the denominator, right? So the conjugate was that orange plus, so we just multiplied by 1 in this form. Then it was a matter of foiling, simplifying, right? Then we had some cancellations going on. That was huge. We got rid of the radical in the denominator. Expanding the numerator was a little bit too far in this case, so we kind of went back. We could have left the numerator how it was, because that's eventually where we went back to. Then we realized that I'm gonna pin dot again. Okay, let me go ahead and play it now. Then we realized we had those two binomials where the signs were opposite, so we factored out a negative 1 from the numerator. Then we were able to get our cancellation. Then at that point, we were able to plug in, because remember when we tried to plug in before, we had a 0 in the denominator, and you can't do that with ever. So if you ever get zeros in the denominator, you got to stop, go back and see where you're making your mistake, or, that's that just kind of stops everything, right? And then we were able to get it all the way down to -4. Okay. So that is a little bit intense. You just have to do your best, keep trying, pushing. That's why I was like, because oftentimes, if you had classmates, then y'all, it's like, I feel like you all learn better from each other. Like when you have at least one student that gets it, and then he kind of disseminates the information to his peers, that usually kind of clicks. Because sometimes me showing all these details is like overwhelming and people shut down. But I hadn't figured out how to bridge that gap, from like what it is to what's digestible. You know what I mean? So anywho, with that, we're going to end the session here. And from one beautiful mind to another, take care. Peace.